All right. Hey, you guys, it's Thursday, spring 2021. And this is interesting just because I'm not using notes from last semester, because last semester this made me really nervous to not do it in person because it is so new. This is something you guys have never done before. Okay. So I really need you to make sure you understand or copy down the notes really well. This is about logs and exponential equations. So it's following. This is the second set of notes. The first set of notes was graphing exponential equations. Okay. So the idea is that the exponential equations go like they start slow and then they go and they just really increase super fast. Okay. Well, sometimes they increase so fast that you end up in these incredibly large numbers. Like, I mean, we're talking not just trillions, we're talking about to the 20th degree or 20 zeros or 100 zeros or whatever. So we need a different way to talk about really, really big numbers and really, really small numbers. So enter in the log. Okay. Log is kind of synonymous with exponent, and that might help you when you're starting to think about these things. Okay. When we talk about logs, we're really talking about the power of the exponent, not as much as the base, but as the power. Okay. So just think about that for a minute. Okay. But we are going to be doing exponents. So here's the thing. Exponential equations go whoop, okay, or whoop. Sorry. Okay. Exponential equations increase. Logs come up and sort of flatten out. They increase really quickly and then they flatten out because it's the exact inverse. So logs undo exponents and exponents undo logs. So in the same way that you learn that division undoes multiplication or the square root undoes the square. This is the same thing. Logs undo exponential equations and exponentials. To exponentiate is how you undo a log. Okay, so I'm going to go ahead and take off the camera. Just kind of, it's funny because I'm doing this on like recorded notes and there's a part of me that's still kind of nervous about it. All right, so here's what you need to write. I'm just going to write some, well, actually, in the beginning, okay, it's just using a calculator to evaluate natural and common logs. So first of all, you need to understand there's a natural log and there's a common log, which is basically log 10 for now. That's all you need to know. So when we're talking about using a calculator, this is just getting you used to the idea that there's a word log on your calculator. We haven't learned anything about what they mean. Okay, all you're learning is that exists. So here we go, calculator. Here we go. So on your calculator, you'll see this word log. And so if you're evaluating this, log 23, oh, by the way, we say log of 23 over 6. Okay, we use the word of between there. So, hey, what the heck happened to my calculator? What happened to my calculator? Here we go, hang on. What the heck? I had a calculator. There it is. Okay, so we're going to go log, and then you're going to go ahead. Dude, what in the, oh, it must be because I'm on my, I don't know why it's doing that. Okay, so log, what was it? Log 23 over 6? Yeah, log 23 over 6. So you just literally put in 23 divided by 6, close the parentheses, and there's your answer. 0.58, whatever, 5835. A lot of times we go down to the fourth number. So let's see what they ask you to. It says yes, to the nearest thousandth. So don't forget that thousandth is, it goes tenths, 100ths, thousandths. Okay, so it's to the nearest 3. This is 10,000. So a lot of times we do certain things to the 10,000s, but we'll do it to the nearest thousandth. So that's here. So it's 0.584. Okay, 0.584. Log square root of 11. Okay, so word log square root 11, done. There you go. 0.52, round up, 1. 0.521, 0.521. Okay, that's all. That's all that one is about. It's just, can you recognize it on a calculator? So I'm going to increase this. I could not make it go bigger for some reason. I don't know why. Okay, there's also this other log. There's two logs. Log is base 10. So we'll talk more about this, but think about this as like 10 to the third, 10 to the fourth, 10 to the fifth. Basically, the base is 10, and then we're just coming up with an exponent, okay? Log, natural log is represented like this. It is the natural log. And it is the opposite of the e. I told you about e to the x. E is this number. It's too hard to explain what e is, to be honest with you, especially at this level. In calculus, you might understand it a little better. But natural log has to do with base e. Log without a base is base 10, just so you know. So on the calculator, when it says log, it means base 10. When it says ln, it means base e. None of this makes sense. It's okay. Just plug in the numbers and you'll see that you get a number. And at this point, that's all we need. Okay? Log, did I do that right? ln of 4 divided by 5. Yeah. Okay, negative 0.223. Okay? Negative 0.0223. And then ln of 30.8. So ln 30.8 done. 3.428. Okay? 3.428. I'm going to go ahead and pause this for a second. All right. So now let's take a look at the next one. Nope, that didn't work. Let's try this. Now. All right. Now you're going to learn about how to convert between logs and exponential equations. So here's what you need to write. Okay, here's what you already understand. Y is equal to b to the x. Okay, notice this is what makes it an exponential equation. The exponent, okay, is the variable. I should put it the other way. The variable is in the exponent. Okay, the variable is in the exponent. That's what makes this an exponential equation. Okay, the base can change. B stands for base, and y, of course, is just the value of the function. All right, so we understand this. So to convert it, actually, I'm going to use colors. Y equals b to the x. Okay, you can go back and forth between log notation and exponential notation like this. Okay, it goes log b, okay, of x equals y. And wait, no, it's log b of y equals x. My bad. I know this. Log b of y equals x, and x is purple. Okay, here we go. Okay, in other words, do you see how the word log is on the left-hand side? And it would be log base b, this is how we read it, log base b of y is x. So in other words, the log is x. This number is the exponent, see? So a log is a way of talking about exponents. It's changing this. So for example, 5 to the 1 equals 5. Okay, first of all, that's true, correct? 5 to the first equals 5. So what we want to rewrite this as, okay, what's the base? B, right? Log, okay, so where are we? Log 5 of 5 equals 1. Do you see it? So the 1 is the exponent, the base is the base, and the answer is here. So you could read it backwards by going 5 to the first equals 5. That's how I do it a lot, because I don't really comprehend logs as exponents very well. But 5 to the first equals 5. That's how it reads. So let's take a look at the second equation. No. Sorry. There we go. I need to lock this down so I don't lose it. Lock. Okay, so log 2 of 1/16 equals -4. So it goes like this. Log, okay, you've got the base b, log 2, okay, of 1/16, which is the y, which is what color? Blue, okay? 1/16 equals -4. It's purple. Okay. So, see, I've colored them the same. I didn't write the word log. So it goes like this. 2 to the -4th equals 1/16. 2 to the -4 equals 1/16. So basically, when we talk about a log, if we say log is -4, we're talking about an exponent that is -4. See, log 2 of 1/16 equals -4. 2 to the -4th equals 1/16. Keep this handy. This will save your life. This conversion will save you on most problems. Even when it seems really difficult, sometimes if you just come back to that, you'll be fine. So here's some for you to try. Okay. Okay, see if you want to pause it and try it yourself. Okay, so we're going to go log. It's already in log, so we want to go to exponential. So again, this is the base. So 2, this is the exponent to the -5th equals the answer, 132. And that's true, right? 2 to the -5th is 132 because that means 2 to the -5th means 1 over 2 to the 5th, which is 1 over 32. All right, so this is the new one. So take a look. What is the base? The base is 7, exponent is 2. So we're going to go log 7 of 49 is equal to 2, because 7 squared equals 49. Okay, so hopefully you're starting to get it. I don't think I did a ton of these because you are going to get to practice them. Yeah, here's one more. Okay, so this one, you want to go to exponential. So that's the base, that's the exponent, equals 1/49 again. And I recommend you write this until you get it. Log base b of y equals x goes back and forth to y is equal to b to the x. Those two are interchangeable. So if you need to, write this down so you always know where to go. And then all you're doing is putting things in the proper place. Here is the base, that is the exponent. So we're going to go log base 9 of 1 equals 0. And that's actually going to become something that we need to, that's going to become a property. There's some of these that are going to become a property. Is it a property? I want to say a rule. Log base b of 1 is always going to be 0. Because b to the 0, no matter what base, it could be a million to the power of 0 is always going to be 1. So this is one of the log rules, okay? I'm going to also give you this one since I'm here. Log base b of b equals 1, because b to the first power equals b. These are two really common ones to know, okay? There's more, lots more. All right, take a look at the next one. So now you have natural logs. Natural logs are base e, so it goes like this. Y is equal to e to the x is interchangeable with ln base e of y equals x. So it's the same thing. We still put the base with the base, we still put the answer here, and we put the exponent there. All right, so we got to rewrite this. Sometimes what I do on natural logs, especially when I was first learning them, I would add the little e. You don't have to put an e because we know that the natural log is base e, but honestly, sometimes it helps to put it there. So then that goes to e to the y equals 2. exponent is y. There it is. Okay. This one backwards. ln, and you don't have to put e because we know it's e. Okay, ln, put it if you need to. Okay, of x equals 6. Exponent always goes on the right-hand side. Okay, if you want to pause and try your own on this one, go ahead, pause. I'm going to give you the answers. Okay, let's see. All right, so we're going to rewrite this as a log. It's e, so it's ln of x equals 5. Just remember, always the 5 is the exponent, goes on the outside. I'll write this one. You can add the e if you need to so that you can write e to the y equals 7. Again, that's how you get that. All right, now that you know how to convert them, now you're going to have to evaluate them. Evaluating means find a value. Okay, notice there's no exponent here. There's no variable. You don't have an x anywhere. You're literally just solving them. However, if it helps you to put an x there, you certainly could. I used to do this when I was younger because I didn't like evaluating them like this. Like I wanted to put an exponent there, and then I would do 6 to the x equals 136. Like I would convert it to exponential form, and then I could see that x was equal to -2. Okay, and if you don't know that, is 6 to the x is equal to 136 is 6 to the -2. The bases match, so we can equate their exponents. Now, some of you guys are probably better than me, and you could probably just look at it and be like, oh, that's -2, because 6 to the -2 equals 136. Okay, it's up to you. Take a look at the next one. It's basically saying 4 to the what power equals 64. And the answer is 3. 4 to the third power equals 64. Okay, if you were me and you were a little kid, you would put like that. 4 to the x equals 64. 4 to the x equals 4 cubed. And then I would know x is equal to 3. All right, take a look at the next one. It's so tiny, I apologize. I'm going to rewrite it. It says log 9 of 1/9. What is that? Okay. If you know it, just say it. If you don't know it, change it to exponential form. Just put an x here and then rewrite it. And then you would get 9 to the x equals 9 to the -1 to bring it back up. And you would have x equals -1. Okay. Log. Okay, this one. Do you see how it has no base here? Since it has no base, that means that it's base 10. When we write the word log and there's no other base, it's base 10. Okay, so again, if you know the answer, jump to it. Okay, it's basically 10 to some power equals 1,000. Of course, the answer is 3 if you know it. Otherwise, you can go 10 to the x equals 1,000 and then figure it out. How could you get this into base 10? It's 10 to the third. So x equals 3. Okay. Okay, now let's go ahead and solve. This is the very beginning, solving the equation. The easiest way to solve these equations is typically change them to exponential form. So you have log base x of at 1/100th equals 2. So it's saying some base to the second power equals 1/100th. So oftentimes it's easier to change it to this. X squared equals 1/100th. And then it might be easier. You could take the square root of both sides and you would get 1/10. Because 1/10 squared equals 1/100th. Make sense? All right. Let's try another one. Okay, log x of 181 equals 4. So some number to the fourth power equals 181. Okay? Again, I always like converting it. It just makes it easier because I understand exponentials so much better. So to find x, I would take the fourth root of both sides. X And then the fourth root, what times what times what times what is 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, right? 1/3. And that's the answer. Look at this one. It's log base x of 81 equals 2. So this one's a lot easier to see. What number squared is equal to 81? And then you could probably just go x is equal to 9. Otherwise, you get x squared equals 81. Change it to exponential, solve for x, and you'll get x equals 9. And that is it on the notes. Those are the beginning baby steps to logs.